This is my table showing doctors, nurses, and the year. And this here is a scatter plot of the nurses in Nevada. All I did was just put the graph in, or the data from the table in, and made it into a scatter plot graph, like so. And then this is a graph for the doctors in Nevada. And I did the same thing for that. Next, for my linear graph, all I did was went to the graph and right clicked and added a format trend line, and then I clicked on linear, and then the graph came up, and then I edited it so that way the line would go through the point and extend on. And then I added titles and cleared off the other extra stuff that wasn't needed. And then I did the exact same thing for my nurses graph. And then for the polynomial graph, I did the exact same thing. I went to format, trend line, and I selected polynomial, and then the graph came up, and then I added titles and made it so the line extends out and moved the number so it's easier to see. And then I repeated those steps again for the nurses part to find nurses in Nevada. And this right here is a graph showing the nurse to doctor ratio in Nevada. And then the bottom, there's my equation, and I got that's taking the linear functions from each graph from the doctors and nurses, and then putting the doctors on top, and then the nurses on top, and then the doctors on bottom are divided by the doctors. And this is my final graph, which is limits at infinity, and it basically just shows, it puts like an asymptote on there and shows that the numbers of doctors and nurses like would never pass that number if it just keeps going up. Like the ratio will never get under that if it kept going, if the numbers kept increasing, because there'd be an asymptote there.